All right, folks, let's get started. We have 2 more sessions this afternoon. First up is Iain, who's going to give us an update on where GDB and bin utils are. So, session on debugging, which hopefully will be fun for everybody. And take it away, Iain.
Yeah. Hello, I'm Iain Buclaw. I am the maintainer of GDC, and I also do some work part of the Free Software Foundation projects around GDB and bin utils in particular, trying to get D support in for that. One thing that I've noticed over the course of the last year is that there's been a shift in focus from getting the D language stable to the point where you can start writing large, big production software without the compiler spewing out odd error messages at you, to now we've finally got big production software in use. Now we don't know how to debug that. And hopefully some of the things I've got in the pipeline will help push that and make it easy for you. In terms of debugging, I'll question more to the speakers who have already raised this as an issue, but in terms of environments, what do you use to debug? So are you on Windows, OS X, and Linux? So vast majority of you, Linux, GDB, excellent. So this is for you. This is the general format of the talk. This guy here is the mascot for GDB. His name is Archers. He's a sort of fish that sits down in a sort of small ponds eating bugs all day. Just a sort of general introduction to this. Whilst it would be wonderful if we could all write programs that are guaranteed to work correctly and never ever need debugging, until that day comes where everything is safe, pure, and no throw in Phobos and runtime, we're typically going to go through a programming cycle of writing a program, compiling it, executing it, then go through the dreaded scourge of debugging it, and then repeat from compiling to debugging, compiling, debugging, until that halcyon day comes along where everything is perfect and tranquil and nothing more to do. That day will never come. So, what's a debugger? A debugger is an environment, a bit like a virtual machine, that allows you to inspect and introspect just exactly what a program is doing at a particular point in time. Typical errors that may be easier to find with the help of a debugger include segmentation faults, stack overflows that you can just use a backtrace to see where your program is looping in, random or uninitialized values. Not that we get too much of that in D. Things that are less likely but also do help with the use of a debugger is also out-of-memory race conditions. Race conditions are easier to find if you are, let's say, you pause one thread to let other threads speed ahead, and suddenly you don't see the bug. You then acknowledge that as, OK, we need to pause things and get things going. And lastly, external dependencies. So is it actually a bug in my software? Is it just I'm caused a bug in somebody else's program and I need to raise this? So what is a debugger? Whilst it's possible in D to actually debug programs just by printing out information using a handy little debug statements, in my opinion, it is much easier to use a source-level debugger that allows you to step through the program source, both forwards, and support is coming in place to actually go backwards in your program as well, although that requires hardware support. And setting breakpoints, signal traps, so if you want to catch an interrupt of a user interrupt, and to actually print variables, backspaces, and optionally call functions whilst you are in this debugging state. So if you want to find out what would happen if I pass this arbitrary value to this function and get the result, this is what you can do. So how does this work? It's kind of a two-way relationship going on here. So there needs to be an alignment between the compiler and the debugger. The compiler emits debug information, and then the debugger reads that and interprets it. This information typically consists of things such as various types you're using in your program. So if you've got user-defined structs or classes, constants and functions that are represented in your program, as well as source-on information, so that you know whereabouts this is within your program, and variable binding information, which is so from the current location that you are in your program, you know what's exactly immediately accessible to you. Things that are interesting to know, but not really required for this talk, are that there are a number of various competing debug formats, such as dwarf, stabs, CV, PDB. But by and large, there are two ways to go about storing debug information. First one is in separate compilation modules. This is used by GCC, and the other one being everything's a huge database, which is typically the one used by NSVC. So what really sort of started this? This is a project I got working on at around about end of January, start of February time. Albeit, I got drawn to this particular bug, GDB printing wrong values in TLS variables. I think Andre started doing bounty source, I believe it's called, and started raising all these things. I just sort of had a look through some of the things, and what really stood out to me was that the number of GDB bugs that had been placed bounties on. And so I sort of opened it up, gave it a try in GDC. Of course, GDC being quite tied to GDB, I couldn't really reproduce it. But actually what concerned me in a way is that I could not reproduce this problem if I was to use DMD and compile with the GC flag. And so I then took the object files of DMD compiled with G and GC and compared the two. And what surprised me was that these are completely identical, minus one difference being that with GC, we have DW lang C89 rather than DW lang D as the language that this has been compiled for. So I really sort of found that the fact that GC works better in GDB seems somewhat accidental. And some of the things that really sort of probed into this is when I actually started opening up GDB and debugging itself. A really nice experiment to try. I don't recommend it. But what happens when I was stepping through it, I sort of found that GDB started building an environment that wasn't really valid. It didn't really know how to handle certain things that are emitted by D. And what's worse, when you try to print values, it goes through a C++ expression evaluator. So it tries to treat it as if it's C++ code. Unsurprisingly, it fails at this, and what's even more surprising is that pretending to be C may not actually be the correct solution. So in particular, there are quite a lot of things that are represented in D that do not map to C++. And in fact, other debuggers which also support C, or other platforms that support C and have a debugger for C, they may be quite confused if they come across things such as classes, methods, and virtual vtables. So after having studied this, I sort of came to the shocking epiphany that this is actually not a compiler issue. As much as I want to blame the compiler for this, well, let's just put it one way. When someone last asked me, how does GDC work, I drew this picture. I am very quick to actually blame the compiler for anything. If things don't work, I say, OK, it's my problem, let's look at it, fix it. But this is what actually shocked me when actually the tool that's broken is the debugger itself. And it really sort of came to ask me the question, why does the debugger work this way? You know, something must be fundamentally wrong with the way that GDB treats the dwarf information that's emitted by D compilers. Well, something else actually drew to my attention is this one. Someone actually took the time to actually go through the dwarf symbols emitted by DMD and actually commented on what he thought was wrong and ways that he can improve it. By and large, it sort of attributes most of the problems to, so say, if DMD worked in this way, debugging would be much better. I think not. I think that many of the things that he raises can actually be fixed externally within GDB itself, and it's just sort of the small niceties on top of that that actually help push us over the last hurdle. So, after having a look at that sort of list of things, it really sort of got me thinking, what can I not do in GDB? So, does anybody have any things that they wish to bash on about using GDB? Can I have a microphone over here?
Tuples?
Tuples? What's wrong with tuples?
Picking out just one of them and pulling out just one of the pieces of a tuple and having it print when it's a type tuple, and saying, I want to talk about this one, and it says, that name is completely different, and then trying to track it down.
Okay.
Mixins.
Mixins is a very big problem. There really needs to be a way, well, I think the problem with mixins is how the compiler emits the strings when it sort of constructs it. It just sort of dumps it into the source file so that things are not in the correct location to where you expect them to be. One kind of workaround you can use for that is actually use the line keyword, so hashtag line followed by the line number. That would then reattribute it back to that position in the file, so you can actually just step through the string that you're passing. How that only works if you if the string which you're mixing in is in the same module. Otherwise, you go to some arbitrary place in the module. At least I believe that's how it works. Maybe Martin will tell me different.
I just wanted to amend on that. I opened the pull request once for having the compiler write every mixin result in a separate file so that you get quite good debugging experience. It's the only way I figured out you have to actually print it. Some file, right?
So another way of doing it is
very valid approach. For debugging like scanner generators.
That's definitely sort of another way to do it in terms of actually when you process a file that has mixins in, you just cache that file somewhere. And so that's the debug information that's pointing to that cache file. Yep.
Because Apple uses an old GDB port, it doesn't work on OS X, so they kind of found that it was unusable and had to use LLDB instead of GDB, just because of that.
Yeah, okay. Anyway, actually, none of you actually raised any points that I'd actually thought about, so I think I'll just stop you all there and actually just continue on. So these are certain things that I'm thinking about. Though I have taken them on board, tuples especially, I haven't actually thought of that. I will take that on board and actually try it out. So, things that I found really annoying. When I start my program, it doesn't automatically break at D main. It breaks at C main. Why is that? Access global names by name. I cannot do this. If I must access a global name, I must find out what the mangle of it is, then print that mangled name. Ditto for accessing functions. You can only access functions by finding the mangled name. Constants are not omitted at all. Talking sort of manifest constants, enums, and also data imported from other modules. So within my current module, if I import sd.math, I'd like to be able to access things that are from sd.math from my current location. accessing class objects, there was no way for you to see what methods are part of a class which you currently have in front of you, or are part of a struct that you currently have in front of you. Some more things. So I've already sort of brushed upon the use of manual identifiers to anything that's static. How you can, mostly by the way that the compiler emits debug information, if you use quotation marks, you can access these anything static through their pretty names. GDB also doesn't understand operator overloading. There's no support for dynamic casting. And I'm forced to use cast operations in a very C style. In fact, I'm forced to use everything in a C style if I need to do anything from within GDB. And also, it doesn't understand D types. If I try to get type information about what this thing is in front of me, it comes back with a C type like unsigned long. These are sort of things, so much harder things, the accessing of D runtime information. Using D operators, such as power, unsigned shift, and identity. And whenever I get to a breakpoint, it tells me that, that I've reached, well, this is actually just run off the screen, it's so long, but I get breakpoints at some location that I cannot comprehend. So, goals of this project. First and foremost, I really didn't want to go about fixing the compiler. I really honestly think that, well, let's put it this way. So, not fixing the compiler, so DMD, probably being a prime example of emitting bad debug code, will remain being bad. But what I intend to do is get it set up so that we're not trying to compete against a debugger that just cannot handle DMD. Get it set up so that it's in a state where changes to DMD instantly reflect better usability from within GDB. Being GDB, this also means that I'm not going to be addressing any problems with Windows because, of course, Visual D rocks and is perfect. Unless you, of course, you use MinGW or Sigwin, but if you're going to be using MinGW, you're probably using GDC for this. So this also benefits you. Likewise with LLVM, I think that LLDB seems, at least to me, better tied with the LLVM backend. However, quite a lot of things that I've sort of raised and done should be able to be moved into LLDB. But of course, if you're able to get a recent version of GDB on OS X, things might work for you. I cannot see any reason why, because what LLVM and GDB do in terms of emitting reading, I can't really see much in the way of things going wrong. So one of the main problems is how to go about coordinating this. For the purpose of testing so far, I've really only kept GDC and GDB in sync with each other. And my current goals is just to get things to a nice, stable use where I don't really run into too many problems when going about debugging, and for the next GDB release, which I assume would be 7.8. I'm not sure how their release schedule works, but recent release was 7.7, so I imagine in the next 8 to 10 months. After it's all been merged in, it'll then be assisting compiler devs, both in DMD and LDC, to actually sort of align the changes so that people can start using this. However, I must stress that most of the changes themselves should really be kept to GDB. This is really the best way to make it possible for everyone to benefit. So, what have I currently done so far? things that I've already merged into GDB and are in the current master is I've taught GDB how to look for dmain. This was quite simple, pretty much just about a dozen lines, because it's already a check is similar done for Ada, Go, and Pascal. So the result of this is when you fire up your debugger, you're instantly brought to the line where dmain is, not cmain. Similarly, there's also no need to set a breakpoint. All you do is type in start, and it sets a temporary breakpoint right at the first line of your main. I've also implemented a built-in demangler. It's mostly complete. It's just missing the ability to demangle templates. Part of the reason is that this demangler is written in C, and it takes most of its design inspiration from core.demangle. There are one or two fixtures that I'm yet to actually merge back into druntime. This is most in particularly mangling of vector types, and there have been quite a few storage attributes added that have not yet landed into core.demangle. And as we can see, when we run a backtrace, rather than getting mangled strings, we get a nice, pretty demangled state. Also note, as a result of this change, we also have the backtrace stop at dmain. This, I think, is didn't intend for that to happen, but I think it's a nice side effect because users typically aren't interested in what happens in druntime. As soon as you hit dmain, you're interested in what happens in your program itself. Next, teaching GDB about the basic types of D. As presented here, the way I typically get around this in GDC is that each type that D has its own type def, so that you can sort of list all this. But actually, with this change, it's actually no longer required for you to actually type def these. And it should be able to sort of pick up just what type a particular variable is mapped to. And of course, you can do various operations just to make sure that it comes out with the right thing. So for instance, car, 42, and mapped to the car value, and ubyte, not being the same as a car, it's but of the same size. Things that are work in progress that I'm sort of kind of it's sort of kind of in the works. They're mostly done, but they're not quite at the point where I'm happy with. So one of the major things I've been doing is actually implementing a runtime expression parser, which is not quite like a REPL, but it allows you to do pretty much anything that you could do in D within GDB itself. As soon as I get to the point where this actually works, I think I'll just sort of call it a day and actually get this all pushed in. Pretty value printing has not yet been sort of touched upon yet, but that is next on my list to go about it. I think it's very important to, especially when dynamic arrays we do have some support for, but it could be better, and delegates have none of this whatsoever. So this is written in Flex, and it's really takes most of its inspiration from the D grammar that's on dlang.org, and also Brian, wherever abouts he is, Brian over there, his D grammar has been of a great help as well in sort of trying to ease things out in terms of things that I found rather odd about the grammar, or that have caused redundancies. But really, I've only really found one or two exceptions. The benefits of writing an expression parser to allow you to run decode from within GDB, some of the things that we benefit from this are that we can have precedent orders match, and we can also add in operators of which D has. So in terms of things that I found that are in the spec but actually cause problems with the Lexa, are pretty much described here. So, and expression, what you see crossed out at the top here is what I had to remove. and right down at the bottom is what I added. I can see why this grammar is described as it is. This is sort of more in terms of the fact that D actually disallows you to have bitwise operations next to and operations. It actually forces you to have it in brackets, but it keeps this in place just so it can catch it. For the purpose of GDB, I wasn't really so much interested in enforcing you to have brackets. I really just wanted to get something working as fast as possible, so I just quickly restructured it. Once the general structure was in place, I then started thinking about adding in useful operations. So here we've got an array, and we can now slice the array in various places, and we can also test to see that bounds checking works on this. I've also added in syntax to allow concatenation, but as we can see here, it's not yet implemented. That's one of the things that I've got sort of high priority on. And also another interesting thing is also the ability to have power expressions in D style. Array operations, again, similar to concatenation, not yet implemented, but I have allowed it so that that syntax can be done. Representing manifests. So it comes to this point when it kind of stops making changes within GDB, and suddenly I need to start thinking about how do I represent this in the compiler. Enums are quite interesting. D enums, of course, you have two sides of the story. First one is enums in the way that we sort of expect enums to be in C or C++. The second one, use case of enums, is in manifest constants. While we can have debug information about enum types, as in C enums, there's typically no debug information about manifest constants because as soon as it hits the to-object file, normally it checks to see if this is addressable and then just discards it. There are two ways we can really go about representing enums from within Dwarf. The first one is using enums. The point of, the limitation of the first one is that enums are really only useful for C enumeral types. So we can use it for integers, but not scalars, and also not Boolean values. With constant in Dwarf, this can be used for any scalar type, but not for aggregates. And when looking into this, I sort of found that I'm willing to sacrifice not representing C enums in the same way of C enums are typically represented as, but instead represent every single type of enum in D as constant values. And this is the kind of result of it. So from an enum value, so my enum, it knows that it's tied to this particular identifier. If we were to change the value, it looks up the enum and pulls it from the same place. My manifest is a manifest constant. How we do this in GDC is for variables that land in to-object file. If it doesn't have an address, we admit that as a constant value in Dwarf. This is safe because it doesn't actually land in the data section. It's only in debug. And we can prove this by trying to take the address of it. There is no address. It's just a value. Another thing that I've been going about fixing in GDC is the accessing of methods. This is done by associating methods with the struct or class which they are scoped under. I haven't yet got to the point where GDB understands where to look for the vtable field and to traverse through the vtable, but this is a quite simple change and will be needed if I want to implement dynamic casting within D. Dynamic cast of D from within GDB. As we can see here, we've got a class, and we can access all the, so toString is overridden from the top here, as we can see, we get back hello. To hash is provided by the main object class. And we can actually call toString from the object class by calling the object toString and passing C. One of the biggest things that I've been spending the last 2 months on has been trying to fix scope lookup from within D. So, going into some more technical details of this, what I've done on the compiler side is all modules are now represented as DW tag module. So, typical example, std.experimental. With imported modules, they're represented as DW tag imported. Selective imports are, so when you import a particular function or a particular value from within this module, are represented as imported declaration. And selective imports are represented as either imported module or imported declaration, but we add the DW at name to say that this is aliased. So, how does this work from within GDB? So, as you typically expect, from, let's say, from within D main here, and we've got at the top of our file importing core time, bitop, runtime, demangle. With the first one, as we import core.time, we are able to access everything from within core.time without having to specify the prefix of it. So print num to string, we get the address. Bitop, because it's aliased, we cannot access things from that module directly. So yeah, pop count not currently in context. To access it, we must use the alias of which we provided it. So bitop.popcount, it gets the address. For the other two, okay, we have pulled in run module unit tests from the runtime module. And of course, as you expect, we can access it just fine. Default trace handler is another function from within that module. Of course, we didn't import it, so it's not accessible. However, we can access it if we use the fully qualified path to it. And lastly, mangle type. Because this is aliased, we cannot actually access mangle type by its proper name, but if we use its alias, it finds the correct locating. So, in terms of testing dwarf in D, this is a topic I've sort of brushed upon with Martin. As I'm making these changes within GDB, it's important that testing these, and in particular when it comes to fixing DMD, that we make sure that there are no regressions in the dwarf output that we emit. So far, the changes that have been merged in have not actually required the use of a compiler. I've just been able just to fire up GDB, switch the language setting to D, and then test various things, such as for demangling, that there is quite a comprehensive list of different mangled strings, and we ensure that demangling works correctly. But when a compiler will eventually be needed, it will be sort of the general case of compiler test case, invoke GDB, break it at a certain location, call a function or try and get a value, and then check the output of that. These tests will be sort of written in a way that hopefully shall be reusable when it comes to trying to line things up with DMD. Things that are currently on my to-do list. Overloading is a big pain. Having looked at it, it's very much C++ centric, and I'm not sure if I can actually quite easily decouple it from C++ so easily, but it's sort of one of the things that I'm sort of hoping to get onto. Likewise, operator overloading. This should be pretty trivial. As we already know that of the different operator overloads, it's just a case of teaching GDB to actually sort of look up to see is an operator overload for this particular type exists. If so, call it. Type off and type ID, similar, and also various other keywords that we want to emit. Properties. Most properties aren't really needed, but some of the two more interesting ones are .init and .classinfo. And I haven't yet started looking at dynamic casting, but again, once I've got vtable accessors in place, that should really come quite naturally. Also, autocompletion is kind of there. but it's got some gotchas if you want to autocomplete from a module to get to a function. So what does work, however, is autocompleting on variables. So as we sort of see here, we've got print c dot, and when we sort of hit tab, we get back all the list of things that we can access from that class. Other things that have been suggested in the time that I've been pushing changes into GDB, in particular with demangling, rather than having it from within GDB itself, it was suggested to actually have this within libvivicy, which is part of the GCC project. The benefit of this is that if we have demangling D in libvivicy, this actually trickles down into most burn utils and any project that actually uses this library. So, by testing it, I've built LD with my demangling patch and tried to compile a program that's missing some symbols. And amazingly, we get back a very easy to read undefined reference. Likewise, we can use things such as object dump. We've got functions name here, calls to functions, demangled. And so why improve bin utils? In my opinion, there's only really so much that you can do from the compiler side in terms of trying to improve things with the tools that already exist. I didn't really want to go about reinventing the wheel by, say, writing a completely new debugger in D. I'm really sort of more of the ethos of, OK, we've got this tool, let's now bring the tool chain to us, rather than try and push outwards. The benefits of bringing things to us is that applications, libraries that use this tool chain also benefit from what I'm changing down at the core. Typical things of this. So this image actually hasn't come out how I'd like to. Sorry for the distortion. So CGB is a this is a very lightweight wrapper around GDB, and one of the best things that I like about it is its color syntax. Before I actually started getting onto a GDB, I'd actually pushed a fix to actually enable syntax highlighting for D applications in this. And one that I sort of came across a couple of days ago was a GUI application called Nemiva. And what really surprised me was just the richness of information with all my fixes currently in. So with the backtrace, all the functions demangled, where they require demangling, and from the stack point of view, the information of so the types, interpreter, object, environment, and that sort of really surprised me in terms of the richness of information that you can now get from just simple changes. So, in terms of finding my current work, it's currently hosted on GitHub under my own name. The actual GDP project itself, where proper fixes will be landed, is in that link. And if you're sort of interested in sort of getting in touch with me and contributing to this, that's my email address. So, any questions? Yeah.
Early in your talk, you had a slide that was talking about stopping backtraces at dmain. What if you're an atypical user and want it to not stop there?
Well, it wouldn't stop there if you were outside dmain, for a start. So,
below dmain, it won't stop there, but if you're above it, it will.
Yes. Timothy? Get microphone.
Visual C++ has a edit and continue feature. I'm wondering whether it's out of scope of a GDB.
Edit and continue.
So while you're debugging, you can edit the code, and it's sometimes, if you're lucky, it'll continue your debugging session with a modified code.
I'm not aware of that for GDB. I've actually never used that feature.
That's for Visual C++, but I'm wondering whether
okay.
it's out of scope for...
Yeah, that's out of scope for GDB.
When do you think that all these changes will go into the main line and be pushed and available to the rest of us? I mean, other than going in and compiling it for ourselves?
Well, that really depends on when the next release of GDB will come out and when distributions will start using it. So yeah, until then, I think all my changes will end up in there from within the next 2-3 months. It's really sort of a case of the most work has really just been getting the expression parser. As soon as I sort of start working on it and doing things, I sort of find that, hey, wouldn't it be really cool just to, if I could sort of do this, that we can do in D from within GDB itself. And yeah, from there on, it sort of slowly grows. It will come to a point where, as I said, if I can do what I typically do in my normal day-to-day debugging life, in terms of, so if I'm debugging a problem in GDC, this being written in C++, I do some rather complex things to actually get the right information. If I can do the same thing for D code, then I'd be happy to actually sort of get it all merged in. So it's sort of, at the moment, I am my own critique of this.
So first of all, I want to thank you for your work on this, because it's extremely valuable in my opinion. I have 2 questions. The first one is, like, GDB introduced Python extensions like some years ago to make better pretty printers. Is it still current? Do they still use this? Have you?
No, I haven't.
Okay.
I can't say I have come across that.
It's kind of weird. Works over some shared libraries. I don't know. Haven't used it in 5 years, so might not be around. And the other question was related to all the dwarf attributes and tags that you were using to model the imports.
Mm-hmm.
What version of dwarf are you using there?
This is version 3.
Okay.
Probably, 3. If I recall correctly, it is version 3. These are actually were part of the dwarf specification as per the Fortran language.
Okay.
Earlier than 3, these actually won't be represented as modules. They'll be represented as namespaces.
Okay. Because like dwarf 4, something introduced quite more complex things to even represent arrays with pointers and length, and you could say like how to get the length and how to get the pointer. So I was wondering if that could be useful for D.
Yeah, it could certainly be useful. As I said, feel free just to sort of erase things out of this chat. It'll be just a case of me just having a look at GDB and seeing what's feasible. By and large, there's not been too many changes in terms of actually reading the dwarf info. Specific changes in terms of reading it have really been code that already exists, but they just don't do that if we're reading dwarf for the D language. Some of these, for instance, structs, classes, and enums, they are strongly typed in D. GDB doesn't know about this. However, the functionality is there for C++ and Java. It's just a case of saying D does this as well. That's really sort of to the extent of reading dwarf of changes that I've made.
A bit of chatter on the live stream about the status of GDC and the GCC trunk.
That was the question for last year.
Apparently it's
okay,
a hot
that's
topic.
kind of off topic to this, but yeah, sure, let's go ahead. So currently it's been put on hold until I get the next front end of DMD merged into GDC, and possibly for 2066 when there's a lot more infrastructure changes to the front end. It's really sort of these changes that Daniel has been making has really sort of given me a chance to not really rewrite, but also restructure a lot of what I'm doing, clean things up, document things, make things a lot more accessible to help people start contributing to GDC. Once it's in that state, it will then be sort of stable again for me to try and resubmit it back into GCC. But whilst it's still got lots of moving parts, I don't really feel comfortable trying to get this merged in.
All right. Well, since I think we have no more questions, another round of applause, please, for Iain's talk. And back at 4:30 for our final talk.